In this video, we will show you how to build a smart thermostat that you will be able to control with your smartphone using the OpenHAB home automation system. First, we will explain what a thermostat is and how it works. A thermostat is part of a control system that maintains a temperature based on a setting. Sensors are the first part of a thermostat and report conditions upon which the changes are made. The second part we refer to as switches. Switches cause actions, like turning the heat on or off. Finally, a controller is needed to change the switches based on conditions reported by the sensors. The things normally switched are fans, heating elements, and cooling elements. We use a special kind of switch called a solid-state relay. It is just a switch that can be controlled by an electrical signal. Each of our modules can control two devices. A number of different types of sensors can be used in a system. The most basic system needs a temperature sensor, and it may be useful to have temperature sensors in more than one room. A sensor with both temperature and humidity is another option. If a heating system uses combustion, a carbon monoxide sensor can add a safety factor to the system. If the carbon monoxide level gets too high, the heating system can be turned off. Other inputs like the time of day are also useful to allow a schedule to be programmed into the controller. Now let's look at a real-world system. The thermostat is connected by a cable to the heating, ventilation, and air conditioning system. If we remove the thermostat from its mounting bracket, we see several wires. The red wire is power. It is a 24-volt AC signal. The green controls the fan. If the red wire power signal is connected to the green wire, the fan will go on. The white wire controls the heating element. If the red wire is connected to the white wire, the heat will come on. The yellow wire is not used in this specific system, but in general controls a cooling element. If you live in a warm climate, you may use the yellow wire and not the white wire. And of course your system may use both, in which case you will need more than one SSR board. The blue wire is the common signal. It is used in conjunction with the red wire to supply a thermostat with power. Now let's look at the other end of the cable. You should be able to identify the thermostat wire going into your system. After removing a couple of covers, we can see where the thermostat wires are broken out of the cable and terminated. By the way, if you forget to turn off the power to the system and touch the red wire to the blue wire, this is the fuse you will blow. Traditionally, thermostats have included the controller, sensor, and switches in an enclosure that would be put in a central point in the living space. With our system, the controller will be an OpenHAB server to allow us to control the thermostat from our computer, tablet, or smartphone. Generally, we will use one OpenHAB server for all our home automation needs, so it will likely not be in the thermostat enclosure. The switches do not have to be in the thermostat enclosure either. Depending on a home's layout, it may make sense for the switches to be at the HVAC system. As long as the sensors can report conditions to the OpenHAB server, you can put one or more of them wherever you wish. This flexibility may make it easier for you to install your system. Let's look at what comes with each reward. Reward 4A is a wired thermostat with basic temperature sensing. It is only $52, but is as capable as many that cost 4 to 5 times more. It includes an RS-232 serial interface that connects to your OpenHAB server via USB. The sensor is a TMP102 temperature sensor, and it has a dual solid-state relay board for switching. If you want to include a humidity sensor, pledge $64 and you will get reward 4B with an HTU21D humidity and temperature sensor instead of the TMP102. Or you can pledge $85 for reward 4C, get a carbon monoxide sensor that includes an HTU21D. If you need the wireless thermostat for $105, reward 4D comes with an EFM48 Wi-Fi processor in addition to the TMP102 temperature sensor. The wireless rewards also come with a 24-volt AC to 5-volt DC power converter. Reward 4E for $118 is the version with humidity sensing, and Reward 4F is the carbon monoxide sensing version. To decide between wired and wireless, most of the time comes down to a single question. Are you able to connect your OpenHAB server to either the existing thermostat location or the HVAC system with a cable? If you can, the wired version will work for you. Otherwise, you will need the wireless version. Now let's look at some examples so you will know which version will work best for you. We will first look at a wireless version that will replace an existing thermostat. It is very easy to install. Using the same components, we can also install the solid-state relays and the power converter in the HVAC system. This will reduce the number of boards you need at the existing thermostat location, possibly allowing a more compact enclosure to be used. The wired versions are similar. In the first case, all the components are at the existing thermostat site with a cable connecting to the OpenHAB server. The second is split with the HVAC system. If it is convenient, the OpenHAB server could be connected at the HVAC end instead. These are great rewards that will give you full control of your system and allow you to save energy and lower your costs.